Good day, ladies and gentlemen. This is Sarel van Grinnen, aka Mr. VG, and we are now starting to get to the second last question on trigonometry. Specifically, this video is about trigonometric graphs. So looking at this question 7 from the Department of Basic Education, November 2021 paper, we are going to analyze this question, look at the fine little bitty things that you might just have forgotten about grade 10 and 11 trigonometric graphs. When we look at this question, I encourage you to try this sum yourself first. So hit the pause button, and when you've done this sum, come back and let's analyze. Let's see what we can do. Before I actually answer the question, ladies and gentlemen, I always love to look at the basic sum. I've already there on the sum, you'll see a little bit there at the top that I've highlighted the negative. The negative in front of the 2 sin x means from 0 where it should have gone up, it now goes down. So the direction has changed. Or some people would say this is a reflection in the x-axis. Whichever way you want to think about it, the graph is going down from 0. Next up, I want to look, what does the 2 mean for the graph? So the 2 is the amplitude. Relating this to the graph, it means the highest point is going to be at 2 and the lowest point is going to be at -2. So that kind of gives me the range of my graph between -2 and +2. The next very important thing you must never forget to do in this kind of sum is the period. The period is just in this case 360. Why? Because there is a 1 in front of the x. If there was something else in front of the x, like we'll see later on, then the period will also change. The period means that this will relate to the critical points or the critical values, which is always the period divided by 4, which means every how many degrees something special will happen. In this case, it will be every 90 degrees. So going from left to right, at -180, -90, 90 and 180. Now let's look at the question that was asked. I was jumping the gun a bit with my writing out here. If I look at g of x, which they ask me to draw, I'm going to relate g of x, first of all, to a normal cos x graph. So let's not write g of x equal to cos x. Let's rather write y equal to that. Okay, let me just get my green pen out here. Y equals to that. So I'm going to always, when moving left and right, ladies and gents, I always look at starting with the original, y equal to cos x. Now y equal to cos x is as an amplitude of 1 and a period of the normal 360, which means the critical point is also going to be 90 degrees. So this is a stock standard normal cos x graph, starting at 1, then going by 90 through 0, and at 180 through -1. Reflecting that to the negative side, so we've got to continue with our little curve. At -90, it goes through 0. And at -180, it goes through -1. Which means my cos x graph is going to look like that. You see, I love to draw always from kind of the middle, from your y-axis. I love to draw. Once I have the original, I'm now going to ask myself, what does that x minus 60 degrees mean? It is a shift to which side? Come on, matriculants, tell me. It's a 60-degree shift to the right, because it's always opposite of logic when moving left and right. So I see negative 60, and actually it is movement to the right. When taking this now to my graph, every single set of coordinates must move 60 degrees to the right. So starting by 0 and 1 must move to 60 and 1. 90 and 0 must move to 150 and 0. And then it's going to end somewhere there at 180. We're not sure exactly where. We can find out if we want to, but they actually don't tell you to figure out those end points. Then my negative 90 moves to negative 30 and 0. And my negative 180 moves to negative 120. And then it's going to end up there. So if I draw my graph, it is going to look like that in orange. Important, they say, clearly show all intercepts with the axes and the turning points. So let's just write that in, exactly like we did with the movements. If they told you, ladies and gentlemen, you have to get your start and your end points as well. It's as simple as substituting into your equation and putting it in your calculator and getting answers. But they're not asking for us to indicate this, so I'm not going to stress about this at all. Let's look at the next question. I've taken a cleaner sketch that comes from the memo, and I'm going to answer the questions that is coming up from here. So question 7.2, it asks, write down the period of f of 3x. Now, I'm not going to take any chances. I am going to substitute that 3x in. So taking f of x and substituting x with 3x, meaning every single x I've got to replace with 3x. Let's take this new equation, negative 2 sine of 3x. What did the 3 change? It changed the period. So the period is now whatever the original one was divided by 3, because there's a 3 in front of the x. So therefore, your period is 120 degrees. Please don't rush this, ladies and gents. Don't rush it. Substitute in, see what it changes. We might try and catch you out. So please, please, please be careful. Looking at question 7.3, it says there, it reads, use the graphs to determine the value of x for the interval between negative 180 to 180. In other words, the whole domain from negative 180 to 180, for which fx minus gx is equal to 0. I'm going to highlight fx with red. I love to use colors. Ladies and gents, please use colors. And I'm going to highlight gx with green. But what does fx minus gx equal to 0 means? It means there's a difference between the two graphs of x of 1 unit, because they're basically saying the difference in the y values must be 1 unit. So what I love to do is take my graph and look at special points on the graph. zeros, ones, twos, where you can very clearly see differences. Because if you go like, if you look at negative 180, we don't even know what the y value is. So what I love to do is just highlight the special points. So first of all, I have that negative 120 there. Remember, there's negative 120 there. Then I have highlighted a lot of other points. You see, there I've got 1 there. I've got 2 there, 1 there again, 0, 1, negative 1, negative 2, negative 1, 0, and 1. And I forgot negative 180 there. Okay? And what am I looking for? I'm looking for a difference between the graphs of 1 unit. Now, I see 2 places where that happens. There and there. Those are the only 2 places where I can clearly see that the difference is 1 unit. Now, please be careful of taking any other points because you don't know exactly what the y values are. But f must be above g because they tell you it's fx minus gx is 1. So there's only one place where f is above g and there's a difference of 1. It's not there, but it is there. What x value is that? X must be negative 30. As easy and as simple as that. So in a sum like this, look at my approach. I highlight all the points where I have whole numbers or numbers where you clearly know what the y values are. Then I look at the difference between the graphs. I want the difference to be 1, but I want f to be above g. And therefore, by process of elimination, I basically get my answer. Let's look at question 7.4. Now, question 7.4, it says there, write down the range, so the y values of k, for which k of x is equal to a half times gx plus 1. Again, ladies and gents, I'm not going to just rush through this. I'm going to start by substituting g of x into that equation. Remember that g of x is a half, or is cos of x minus 60. What does that half now do? It affects the amplitude, which means my range, so my amplitude is now a half. So if I just look at that first part, the half cos x minus 60, the range is now from negative a half to positive a half because the range is a half. Remember what amplitude means. Amplitude means the difference between the middle of the graph on the y and the top value. If I say that is a half, it means from 0, I must only go a half up and a half a unit down. That's why my range is from negative a half to positive half. But now I add 1 to those y values, which means my range is now going to be negative a half plus 1 is positive a half, and a half plus 1 is 3 over 2, or 1,5. And there, ladies and gents, is your range. Oh my goodness. This was actually not that bad, ladies and gents. It was not that bad. But I encourage you, please go and study your theory. You cannot do these sums without knowing your theory. So this is Mr. VG. I'm going to sign out from this video, And I'm going to leave you with a very, very, very important thing to remember. You are almost done with matric. You have very, very, very little time left. So give it all you've got and make sure you get the marks you are capable of. So have a gorgeous, amazing day. Keep well. Cheers.